In recent years, remarkable advancements have been made in the fields of artificial intelligence and robotics, bringing us closer to a future where intelligent machines can seamlessly interact with humans. One company that stands at the forefront of this revolution is Meta. Known for their groundbreaking innovations in AI technology, Meta has recently unveiled an astonishing development: their AI robot that not only interacts with humans, but also learns from them. Through advanced machine learning algorithms, this robot is able to recognize patterns in human behavior. Sounds too good to be true, right? This groundbreaking achievement marks a major milestone in the evolution of robotics, ushering in a new era of personalized and interactive human robots. Let's see what this revolutionary technology has in store for us. Are you ready to meet the robot of the future? Let's get started. This AI is equipped with adaptive learning and real-time adaptation. Unlike traditional robots that are programmed with fixed instructions, Meta's AI robot possesses the extraordinary ability to adapt and learn in real time. This is all thanks to its advanced AI algorithms. This implies that the robot can continually evolve and enhance its performance based on the information it gathers from interactions with us. By observing and learning from its user actions, preferences, and habits, the Meta robot can adapt its behavior, anticipate their needs, and provide highly personalized assistance. Meta has recently announced two groundbreaking advancements that bring us a significant step closer to achieving the creation of general-purpose embodied AI agents. These advancements have the potential to revolutionize the field of robotics and artificial intelligence, opening up new possibilities for the development of highly capable and versatile robots. The first major breakthrough unveiled by Meta is the development of an artificial visual cortex known as VC1. This state-of-the-art visual cortex represents a significant advancement in the realm of computer vision. It has been meticulously designed to support a wide range of sensory-motor skills, encompassing diverse environments and embodiments. VC1 is a product of extensive research and training, with Meta utilizing the vast Ego 4D dataset, which consists of thousands of hours of video footage, capturing individuals performing everyday tasks such as cooking, cleaning, and playing sports. By training VC1 on this dataset, Meta has endowed it with a deep understanding of human actions and interactions within various contexts. The results obtained from VC1 are truly remarkable. It has surpassed the performance of existing models across 17 sensory-motor tasks conducted within virtual environments. This indicates its exceptional capability in comprehending and responding to visual stimuli, as well as its ability to translate this understanding into intelligent actions. That is one amazing way to mimic human perception. VC1's outstanding performance on these tasks demonstrates its potential to serve as a key building block for the creation of more advanced and capable robots. In an industrial setting, robots incorporating VC1 can enhance productivity and efficiency by seamlessly perceiving and manipulating objects, collaborating with human workers, and adapting to dynamic environments. Furthermore, VC1 can contribute to advancements in healthcare, assisting medical professionals in tasks such as patient monitoring and diagnostics, leveraging its deep understanding of human actions and behaviors. The second significant breakthrough by Meta is called the Adaptive Skill Coordination, or ASC approach. This approach enables robots to perform mobile manipulation tasks in physical environments with an impressive 98% success rate. ASC tackles a major challenge in robotics, ensuring that robots can operate safely and effectively in the real world. The ASC approach involves coordinating different skills in robots, allowing them to navigate to objects, pick them up, move them to another location, place the object, and repeat the process. By combining these skills and adapting the environment, robots can accomplish tasks with a high level of accuracy and success. So what exactly do we attribute these groundbreaking achievements to? It's simply data. The development of embodied AI relies on high-quality data that captures human interactions with the environment. However, collecting this data can be incredibly time-consuming and resource-intensive. That's why the team at Meta is excited to share their innovative approach that's revolutionizing the way robots learn instead of relying solely on large amounts of demonstrations or scratch interactions. They're harnessing the power of video data to teach our robots, By using real-world videos of human interactions and simulations with photorealistic worlds, they're scaling up their learning process for general embodied AI agents. With their data-driven approach, the future of AI is looking more promising than ever before. Now here's the catch. Meta AI's pioneering does not stop the simulation-based training. They have taken a bold step forward by successfully transferring the learned policies from the simulated environment to a physical robot called Spot. This remarkable achievement, known as zero-shot transfer, revolutionizes the way robots interact with unfamiliar real-world spaces. By equipping the Spot robot with the policies acquired through simulation, Meta AI has enabled it to navigate and operate within previously unseen and unfamiliar environments. This breakthrough empowers the robot to autonomously perform various tasks, showcasing its adaptability and intelligence in real-world spaces that were previously unexplored. These are just some of the amazing advancements that Meta AI is making towards creating general-purpose embodied AI agents. With a single perception model, the Artificial Visual Cortex VC1, it supports a diverse range of sensory-motor skills, environments, and embodiments. Robots are on their way to becoming more capable than ever before. Embodied intelligence takes a leap forward with the development of an AI Artificial Visual Cortex. According to Meta, they are working on developing an Artificial Visual Cortex. That's right, their FAIR team, in collaboration with academic partners, is paving the way for general-purpose visual representations in embodied AI through egocentric video datasets. And one of their favorite datasets is Ego 4D. This features thousands of hours of wearable camera video from people all around the globe going about their daily lives. This team has been hard at work using this rich data source to develop cutting-edge techniques. For example, they've developed the 3RM model. This uses temporal and text-video alignment to create universal visual representations for robotic manipulation. Another exciting innovation is the VIP model. This can generate actionable visual representations and perform zero-shot visual reward specifications for training embodied agents. And they're not alone in this pursuit. The broader research community is also exploring pre-training visual representations from web images and egocentric videos. Welcome to a new approach for robotic mobile manipulation, adaptive skill coordination. The realm of embodied AI has been a subject of fascination and exploration for researchers. Yet their investigations have merely skimmed the surface of its boundless potential until this groundbreaking moment. A pioneering team of visionaries has unveiled the remarkable innovation known as Cortex Bench, a solution that deftly bridges the existing gaps and propels the field to unprecedented heights. By setting an extraordinary new standard for general-purpose visual representation models, Cortex Bench reignites the pursuit of knowledge in this captivating domain. Within the vast expanse of Cortex Bench's capabilities lie a myriad of sensory-motor skills, meticulously designed and simulated to capture the essence of real-world interactions. An astonishing collection of 17 tasks awaits, ranging from the intricacies of locomotion, where bodies move with purpose and grace, to the complexities of mobile manipulation, where the fusion of perception and action delivers remarkable results. This diverse range of tasks forms the foundation upon which the evaluation of embodied AI models is meticulously conducted. But this isn't just about competition. They're striving for one single model that can perform exceptionally across all tasks, just like the general-purpose visual cortex in biological organisms. At Meta, they're paving the way for the future of AI and setting a new standard in embodied agents. They've also created a revolutionary new approach called adaptive skill coordination. This achieves near-perfect success in robotic mobile manipulation in physical environments. To achieve this, they created the largest and most comprehensive empirical study, a study of visual representations for embodied AI to date, spanning 5+ pre-trained models and 4,000 hours of egocentric human videos from 7 datasets. And they're not keeping those findings to themselves. They're open-sourcing VC1 for the benefit of all. The groundbreaking results show that VC1 is the first visual pre-trained model to be competitive. But with what? With the state-of-the-art results on a diverse set of tasks and their detailed learnings on how model and dataset size and diversity impact performance are shared in their research paper. The future of embodied AI is here, and we're excited to see what's ahead. Imagine a robot tidying up your house like a promoting object from one place to another, adapting to the real world and executing tasks flawlessly. BC-1 and ASC are major steps toward developing the next generation of embodied AI agents. They can perform not only on short horizon but also long horizon tasks. Whether navigating to a specific location, picking up an object, or placing it in the desired receptacle, the robot can do it all. Their ASC technique puts them to the test using the Boston Dynamics Spot robot and the Habitat Simulator. They taught the robot to navigate unfamiliar homes, pick up out-of-place objects, and put them in their rightful locations, all without any real-world training data. And the results speak for themselves. ASC achieved near-perfect performance in two significantly different real-world environments, overcoming hardware instabilities, picking failures, and adversarial disturbances like moving obstacles or blocked paths. Traditional baselines, on the other hand, fell short in the face of real-world disturbances. Many optimistic sci-fi scenarios portray humans as creative, while robots handle mundane tasks. However, AI's generative abilities often surpass humans. The missing element is sensory motor skills, a paradox called Moravec's paradox. It suggests that abstract reasoning is easier for AI than physical abilities. In simpler terms, easy problems for humans are hard for AI and vice versa. The challenge is creating robots that can perform complex tasks safely and reliably. This paradox highlights the gap between AI's capabilities and our expectations. Despite significant advancements, AI still struggles with sensory motor skills. With Meta's cutting-edge AI technology, the robot of your dreams is finally here. With its advanced learning capabilities, it can perform tasks with near-perfect accuracy. And the best part? It learns directly from you. Say goodbye to dull and dangerous tasks and let Meta's AI-enabled robots do the heavy lifting for you. The future of robotics has never been more exciting.